Welcome back to the Hidden Life of Trees, Chapter 10. I had a break for a couple of days because I've been working on a big art project and haven't got around to reading, but I'm back. And the next chapter I'm about to read is The Mysteries of Moving Water, so I think it's going to be a good one. The last chapter I read, I think it was about the United we stand, divided we fall. It was talking about the symbiosis between trees and the funguses and how they work together and share resources and the benefits that the trees gain from giving resources to the fungi and how that the fungi provide for them and support them in so many ways. It's really fascinating. It's stuff a lot of humans could learn from. The many things from trees. There's so much to learn from observing nature, and some of the things in this book are really pointing some of these important things out. So I hope some of you are out there listening and enjoying them as much as me. And thanks for coming back, and thanks for listening, and please share it with people you think might enjoy. The Mysteries of Moving Water. How does water make its way up from the soil into the tree's leaves? For me, the way this question is answered sums up our current approach to what we know about the forest. For water, transport is a relatively simple phenomenon to research. Simpler, at any rate, than investigating whether trees feel pain or how they communicate with one another. And because it appears to be so uninteresting and obvious, university professors have been offering simplistic explanations for decades. This is one reason why I always have fun discussing this topic with students. Here are the accepted answers: capillary action and transpiration. You can study capillary action every morning at breakfast. Capillary action is what makes the surface of your coffee stand a few fractions of an inch higher than the edge of your cup. Without this force, the surface of liquid would be completely flat. The narrower the vessel, the higher the liquid can rise against gravity. And the vessel that transports water in deciduous trees are very, very narrow indeed. They measure barely 0.0 inches across. Conifers restrict the diameter of their vessels even more to 0.0008 inches. Narrow vessels, however, are not enough to explain how water reaches the crown of the tree that are more than 300 feet tall. In even the narrowest of vessels, there is only enough force to account for a rise of 3 feet at the most. But we have another candidate: transpiration. In the warmer part of the year, leaves and needles transpire by the steadily breathing out water vapor. In the case of a mature beech, the tree exhales hundreds of gallons of water a day. Hundreds of gallons of water. This exhalation causes suction, which pulls a constant supply of water up through the transported pathways of the tree. Suction works as long as the columns of water are continuous. Bonding forces cause the water molecules to adhere to each other, and because they are strung together like links in a chain, as soon as a space becomes available in a leaf, thanks to transpiration, the bonded molecules pull each other a little higher up the trunk. And because even this is not enough, osmosis also comes into play. When the concentration of sugar in one cell is higher than in the neighboring cell, water flows through the cell walls into the more sugary solution until both cells contain the same percentage of water. And when that happens from cell to cell into the crown, water makes its way up to the top of the tree. When you measure water pressure in trees, you find it is highest shortly before the leaves open in the spring. At this time of year, Water shoots up the trunk with such force that if you place a stethoscope against a tree, you can actually hear it. In the northeast US and Canada, people make use of this phenomena to harvest syrup from sugar maples, which are often tapped just before the snow is melting. This is the only time of the year when the coveted sap can be harvested. This early in the year, there are no leaves on the deciduous tree, which means there can be no transpiration, and capillary action can be only a partial contributor, because the aforementioned rise of 3 feet is hardly worth mentioning. Yet at precisely this time the trunk is full to bursting, so that that leaves us with osmosis. But this seems equally unlikely to me. After all, osmosis works only in the roots and leaves, not in the trunk, which consists not of cells attached one to the other, but of long continuous tubes for transporting water. So where does that leave us? We don't know. But recent research has discovered something that at least calls into question the effects of transpiration and the forces of cohesion. Scientists from 3 institutes, the University of Bern, the Swiss Federal Institute for Forests, Snow and Landscape Research, and the Swiss Federal Institute of Technology in Zurich, listened more closely. Literally, they registered a soft murmur in the trees. Above all, at night. At this time of day, most of the water is stored in the trunk, as the crown takes a breath from photosynthesis and hardly transpires at all. The trees pump themselves so full of water, their trunks sometimes increase in diameter. The water is held almost completely immobile in the inner transportation tubes. Nothing flows. So where are the noises coming from? The researchers think they are coming from tiny bubbles of carbon dioxide in the narrow water-filled tubes. Bubbles in the pipes. That means the supposedly continuous column of water is interrupted thousands of times. And if that is the case, transpiration, cohesion, and capillary action contribute very little to water transport. So many questions remain unanswered. Perhaps we are poorer for having lost a possible explanation, or richer for having gained a mystery. But aren't both possibilities equally intriguing? That's really an interesting chapter, and so many more questions. And I'm fascinated by the way water moves. Water is definitely one of the things that the more you look at it, the more amazing it is. And the closer you look at nature and the way it moves and behaves and everything, the more you see the incredibleness within it all. Okay, join me again for the next chapter. Take care. Bye for now.